This is Eureka, Grade 6, Module 3, Lesson 5. The opposite of a number's opposite. Sounds a little bit weird, bit of a tongue twister, but it's actually not that hard. Okay, so our open exercise asks us some review questions that everyone should know. So the first one is locate the number -2 and its opposite on the number line. So you can't obviously find it on the number line, but you can answer what is the opposite. So -2 is here. What is the opposite of -2? Correct, it is the same distance from 0 on the opposite side. So -2 is right here. Okay. B says, write an integer that represents each of the following. Now these are not opposites, it's just integer based on what it says. So what is an integer to represent 90 feet below sea level? Right, it's -90. And then an integer to represent $100 of debt. Right, debt is negative, so it's -100. And lastly, what is 2 degrees above 0? Well, above means positive, so 2 degrees above 0 is +2. Next, we have one just like this one on our previous lesson. Joe is at an ice cream shop, only it wasn't ice cream. It was a bookstore, I believe, and a pet store. So in this case, Joe is at an ice cream shop, and his house is 10 blocks north of the shop. The park is 10 blocks south of the ice cream shop. When he is at the ice cream shop, is Joe closer to the park or his house? How could the number 0 be used in this situation? So there are 2 questions we have to answer. One, let's make this a little thinner. When he's at the ice cream shop, that's not part of the question. Is Joe closer to the park or his house? And how could the number 0 be used in this situation? And make sure we explain. Okay, so the shop over here is talking about the same ice cream shop here. They just lessened it to ice cream shop. So we know that Joe is he's at the ice cream shop and that his house is 10 blocks north. So the house is 10 blocks north of the shop. And the park is 10 blocks south of the shop. All right, so that's the information that we know. Now, how can we tell if he's closer to the park or the shop? Go ahead and pause this if you need to get a piece of paper so you can draw a number line. And since it's north and south, I would suggest doing a vertical number line. Go ahead and figure it out and see if you can answer the questions. Okay, so I made a pictorial representation of it using a vertical number line. I put the ice cream shop at the 0 because that's where Jose is, and I might even put Jose there. There's Jose. And he's at the ice cream shop, and his house is 10 blocks north. Well, I know that north is positive in this case, and the park is 10 blocks south, and so in this case, south is negative. So, when he's at the ice cream shop, is he closer to the park or the house? Well, hopefully you realize that it's the same distance because they're both 10 blocks. And how could the number 0 be used? Well, I hope you also realize that 0 was the ice cream shop. So what you should have written is something along these lines. Okay, hopefully you would have written something along the lines as Joe is the same distance. Why did I say so? Okay, so Joe is the same distance from his house in the park when he's at the ice cream shop because they are both located 10 blocks away from the ice cream shop, but in opposite directions. 0 is the ice cream shop. All right, moving on. Okay, so now we're really going to get into the nitty-gritty of the lesson. Example 1, the opposite of an opposite of a number. And this is how we explain it. It may seem confusing, but just hang in there. What is the opposite of 8? And how can we illustrate this number on a number line? Well, we start by looking at what number 8 is units to the right of. So what number is 8 units to the right of 0? If we started at 0, then 8 would be, to the right of that would be a positive 8. Okay? And how can we illustrate that on the number line? Well, we have to just figure out how many numbers we have here. And there are about 17, so if we started 8, 7, 6, 5, 4, 3, 2, 1, 0, and then -1, -2, -3, 4, -5, -6, -7, -8. So if we're illustrating locating the opposite of 8 on the number line, well, 8 is here. Here. So finding the opposite of 8 would have to be all the way back here to -8, because the opposite of positive 8 is -8. We learned that in the last lesson. So what is the opposite of 8? We just showed -8. That's easy enough. Now what if we had to do the same process to find the opposite of -8? So go back from -8 to positive 8. To find the opposite of -8, it's positive 8 right here. So using the same process to locate the opposite of -8, what's the opposite of -8? That's positive 8. Notice now that these two numbers here are the same. So here's the whole crux of the lesson. The opposite of an opposite of any number is the original number. And that's what you need to know. All right, but let's see if we can't talk about, there's a way of writing it that can be kind of confusing. So let me fill in. We're not going to worry about persons on this one. And I'm going to fill in, instead of cards, I'm going to fill in the number here, okay? And then we're going to talk about how to write those down. Okay, so when we start with the number 4, the way that we write it as an equation is we say we want to find out the opposite of 4. So that's what they have that here. So we would write the opposite, and then in parentheses we write what the original number is. In this case, it's 4. So the opposite of positive 4 is going to be, and the answer is -4. If we wanted to find out the opposite of that, the way we write it is the opposite of -4. And that is back to 4. Okay? So 150, it's the same thing. We want to know the opposite of 150. And that's going to be -150. If we want the opposite of that, it would be the opposite of -150, which is then back to +150. Okay, now here's where it gets tricky. If we want the opposite of -6, we're still going to write the opposite, and what we're looking for is a -6. That's the original number. It goes inside here. So the opposite of -6 is +6. Now if we want to find out the opposite of that, we're going to write the opposite of the opposite, and that goes back to being -6. I know that sounds weird, but this is what we're looking for right here. So if we want the opposite of -9, it's going to be a +9. If we want the opposite of that, the whole thing turns out to be the opposite of -9, and that comes out to be -9. All right? With the original being on the inside here. Okay, so let's look at number 1. Write the opposite of negative 10 as an equation. So the first thing we're going to write is, this is how you write it. The opposite of negative 10, that's your number, equals, and then whatever that is, negative 10. What it looks like in a number line is the opposite of negative 10, and then the opposite of that, the opposite of the opposite, brings you right back to negative 10. So again, in general, the opposite of any number is the original number. And that's what you have to memorize more than anything else, okay? All right, so here's how we write it. You can do this one. The opposite of negative 7. Just straight out the opposite of negative 7. Okay, well, you can write the opposite of negative 7 is positive 7. What we're looking for here, and that will be a correct answer if you guys wrote that, that's fine. What I want you to think about writing, though, is writing it as an equation. So the equation looks like the opposite of negative 7 equals positive 7. So for B, the equation would be the opposite of the opposite. So the opposite of the opposite of, every time you say of, you put a parentheses, 25. Then you got to close these other parentheses here. And that's going to equal, and it doesn't matter how, as long as you get this written down, you know it's going to be the original number, which was 25. All right, so try writing the equation for C. The opposite of 15. How do you write it as an equation? Okay, you write the opposite of 15, and that is going to be negative 15. Okay, so now D. How do you write the opposite of negative 36? Okay, you write the opposite of negative 36. And that will equal, the opposite of negative is positive, so positive 36. All right, one more, maybe two. Jose graphed the opposite of 3 on the number line. So here's what he did. First, he graphed a point P on the number line 3. So this is where he graphed his 3. Okay? Then, it was 3 units to the right of 0, sorry. Next, he grabbed the opposite of P on the number line 3 units to the left of 0. So this was the first one. And then he did this one and called it K. So that was the opposite. So that was the first opposite. Finally, he graphed the opposite of K and labeled it Q. So the first question says, is this diagram correct? Is it correct how we did it? Yes or no? Okay, the correct answer is yes, he did it correctly, because the opposite of the 3 was the negative 3, so this was negative 3, this was positive 3, and then the opposite of negative 3 brings you back to the original number, which is 3 again. So the next question says, what's the relationship between the points? It's either going to be the same or opposite. So for P and K, are they the same or are they opposite? Right, they are opposite. How about K to Q. Are they the same or opposites? They are also opposites. And lastly, how about P and Q? Yeah, they're the same. All right, not too bad. Let's read each real-world description. We're going to write the integer that represents the opposite of the opposite, okay? And we're going to write it as an integer. And then we're going to write our show our work. So, the first one is a temperature of 15 degrees Fahrenheit. So, a temperature rise of 15 degrees Fahrenheit would be positive 15. Now, if we wanted to write the opposite of that, the equation would look like the opposite of, and our original number is 15. Our answer is going to be 15. Very good. So, B says, what is a gain of 55 yards? Well, we know a gain is positive, so that's 55. So you write the equation for what the opposite of 55 is. Okay, you've written the opposite of 55, and that equals 55, because the original number was 55. See, it's not that hard. Okay, what about C? A loss of 10 pounds. It's the opposite of that. Well, the opposite of a loss, which is negative 10, makes negative 10 our original number, so our answer is also negative 10. All right, so now D. A withdrawal of $2,000. What's the opposite of that? Okay, well, the opposite of a withdrawal, which is negative 2,000, is negative 2,000, because that's the original number. That's the original number. That's the final number. All right, number 4. Write the integer that represents the statement. And it says to locate and label, but we're not going to be able to do that. So, all we're going to do here is write down the integer. The opposite of a gain of 6. Right, the integer is negative 6. Next one, the opposite of a deposit of $10. Yeah, the opposite is negative 10, because deposit is positive. Okay, here we go. The opposite of 0. Well, in the last lesson, I hope you remembered that 0 does not have an opposite. It's its own opposite. So the opposite of the opposite, we can say as many times as we want. It's still going to be 0. All right, D, the opposite of 4. It's always the original number, so it's 4. Letter E, the opposite of a loss of 5. Well, you have to know that a loss of 5 means negative 5. And when you have the opposite of the opposite, it's just going to be the original number. Okay, so the opposite of an opposite is the original number, regardless of whether or not it's positive or negative. So let's try this again. The opposite of negative 4. Let me write it correctly so we have it. The opposite of negative 4 I need to do the opposite of the opposite. So let me write it the way I'm saying it. The opposite of negative 4 is going to be the original number, negative 4. So if I want to do the opposite of positive 5, the original number is positive 5, so it's positive 5. If I said the opposite of negative 165, the original number is in the parentheses here, it's negative 165. Whether you have it in words or whether you have it as an equation, it doesn't matter, it's still going to be the original number. And that is the whole point of the opposite of an opposite in Lesson 5. Thanks.